Welcome to Geometry Pre-AP. Tonight we're going to talk about proving triangles similar. We're going to have a bunch of practice with this in class. So first thing I want you to make sure you do is write down the essential understanding. You won't have to do any of the direct vocabulary, though this might be a nice one to have indirect measurement. You can show that two triangles are similar when you know the relationship between only two or three pairs of corresponding parts. Sometimes you can use similar triangles to find lengths that cannot be measured easily using a ruler or other measuring devices. This is where the indirect measurement part comes in. All right. So, first, postulate 9-9 is the angle-angle similarity. Make sure you use this symbol here, angle-angle similarity. It says if you have two angles, one triangle congruent to two angles on another triangle, the two triangles are similar. They're not congruent, they're similar. All right? And then theorem 9-1 is side-angle side similarity. It means you have to have two sides are proportional to two sides on another figure, and they have to have that angle between them. So if I had this is a 1, and this is a 3, and this is a 3, and this is a 9, I can check the proportion AB, which is 1, over QR, which is 3, equals 3 over 9, and I get 9 is equal to 9. So the proportion checks out, and the angle checks out, so this is side-angle side similarity. You have to have measures for this. You can't solve for algebra to get this. You have to know these. All right, and finally the side-side-side similarity. So I'm going to put some numbers in here. In this one, you have to have three proportional sets of sides. So if I take AB, which is 1, over QR, which is 4, equals AC, which is 2, all over QS, which is 8, and then finally 3 over 12, they all reduce down to 1/4, 1/4. So 1/4 equals 1/4, which equals 1/4, and so this is the side-side-side similarity. These are not congruent triangles, these are similar triangles, because we don't know the angle measures on the outside. Their sides are not congruent either. Their sides are proportional. Okay? All right, so you'll have to do a lot of practice with that. You have a couple sheets worth of determine whether the triangles are similar or not, and you have to check this proportion. So here we have, are these two triangles similar? All right, so we see one angle in each, and you need at least two angles. But remember that because these are vertical angles, these angles are also congruent. So therefore, these triangles are similar by the angle-angle similarity. Now, if you look at this one, they don't have two angles the same. But we can find the missing angle for each one. And when we do find the missing angle, this is 70 and this is 30, so that means this missing angle is 80 here, which makes 180. This one over here missing was 25. So therefore, no, these triangles are not similar by angle-angle similarity. The angles have to match up. Because you have one angle that matches, you have to check that other unknown angle to make sure. All right? All right, so verifying triangle similarity. So are these two triangles similar? So we need to set a proportion up and check each set of sides to see if they're proportional. How do you know which side to match with each other? Well, that should be common sense. Smallest side, smallest side. Middle side, middle side. Larger side, larger side. So when we check here, we can use the lengths of the sides to find the corresponding pieces so we can set a ratio for each side. So we can look here, and I have the blue sides, the red sides, and the purple sides. And so my shortest side would be AST to XV, and so when I set the ratio, I get 2 to 3. My longest side would be USXV, which is 10 over 15, which is also 2 to 3. Now, my middle side would be TU to VW, which is 8 over 12, which reduces to 2 over 3. So because they all have the same ratio, these are similar by side similarity. Remember, all the sides were known here. None were unknown. If you have an unknown side, you can't use side similarity. You have to know all the sides. All right, so now this other one. If you don't see it here, there are two triangles inside here. There's a small one on the inside and another one on the outside. So don't treat this any other way but two separate triangles. So when I'm working this problem, I want to say angle K is congruent to angle K. Okay, and so that we know this angle is congruent to itself for each triangle. So we have that one triangle in here, and then we have that other triangle in here. And so this is the 8 and the 12, and then this is the 10 and the 15. And so we have 8 over 10, and then we have 12 over 15. They both reduce to the same value. They both have that angle on the inside. So this one's going to this one, and so this would be side angle side similarity. Okay. Be careful not to try to do like, don't do this. So if you try to do 8 over 2 equals 12 over 3, that worked out, but that's not really a true statement. Okay, you can't prove that's true. And you can ask me about that tomorrow if you want, and I'll explain it to you a little bit better. All right, so here are 3 practice problems. Please determine, it says determine if these are similar or not. So please work them and see. So this will be angle-angle similarity. All right, for this one here, hopefully you check the angles. This is what, 50, 60, so that leaves 120 here. I can always see the angle stuff, so these are not similar. And finally, this last one, we'll have to check that one. We're done with this one. This one is side angle side similarity. And so this one will be triangle SQP is similar to triangle STR. This will be triangle GFH is similar to triangle JKH. And since that one's not similar, there's no similarity statement. All right, so I want you to practice these 2 problems, find the measure. So pause the video, do both these problems, and then we'll let you check your answers when you're done. Okay, so you should be done with these. Check that answer there. Oops, I didn't mean to have that in the pen. All right, there's your answer there. X is equal to 180, and for this one there, X is equal to 13.75. If you messed up on this one, let me point something out to you. How'd you use that? 5 feet 6 inches. Isn't that 5 feet 5.5 feet? If all our measurements are in feet, you need to put it all in feet. All right, so maybe that'll help you get that one right. All right, so I want you to know that these 3 problems, I want you to try them and attempt them. The first one is done by square root method. The next 2 are quadratics. Neither one of them have to be done in slip and slide method as long as you know how to work through the process. So attempt all 3 of these, and I'll show you the answers in a minute. And then if you had a problem with these, you'll need to ask when you come to class the next day. Okay, so you should have here x is equal to 6, x is equal to 20, and x is equal to 10. And those are your 3 answers. So if you had a problem with these last 2, make sure you ask when you come to class tomorrow. We can go over those. And that's the end of our video.